Hi everybody, so today we are going to do the atoms worksheet. You will need 4 colors, either colored pencils, crayons, markers don't work very well unless they're highlighters. So go grab those. Okay, so this is the sheet that I am referring to. Just gonna erase it all. Maybe. Alright, so if I could just get my pen to work. Why is it not working? What is going on? Why do I don't want a sticky note. Really? Okay, come on, pen. There we go. Okay, starting now. We are doing the atoms sheet. You will need 4 colors. Blue. It works best if you grab either highlighters, crayons, or pencils. Markers are kind of hard to see through. So you'll need blue, and that's going to be our protons. And you will need yellow for our neutrons. And red for our electrons. Green for our nucleus. So fill in your keywords section. Then grab back your red pen, and we are going to zoom in here. Okay, so electrons, we like to write them as a circle with a negative in it, or another way would be negative E. So, with that being said, electrons have what charge? If there is a negative in the circle here, and we write it as negative E, what charge do you think it has? Hopefully you said it has a charge of -1. Okay, and then I also like to color the words in just so we have a good color-coded page. Alright, so now we need our blue pen. So we're going to move down to protons. So protons is the positive circle. So if electrons were -1, then protons must be hopefully you said +1. Right? How I like to remember it is I turn the T into a plus sign. You could also say P for positive. Alright, moving on down. We now need our yellow. Color in our blank circle. So what charge do you think neutrons have? Hopefully you said that they have no charge because they are neutral. And I like to remember that as neutrons neutral. Alright, moving on down. Now we need our green. The nucleus is made up of blank and neutrons. Oh, wrong pen. What do you think? Alright, so if you haven't gotten there yet, I am going to go over here. And we are just going to draw the nucleus, which is an invisible force field around the center of the atom. As I color code this atom, which you should do at home as well. Don't forget this little one in the center, that is one. Okay, nucleus is made up of neutrons. We have one other thing in there. What is that thing called? It's blue, or we're representing it as blue. It's not actually blue. All right, hopefully you said the nucleus is made up of protons and neutrons. The amount in the nucleus is the same as, oh, I don't want that in blue. It is equal to the atomic weight, which is the same as atomic mass. Those are the same thing. One has decimal points, one doesn't. Okay, so now we know that atoms contain electrons, protons, neutrons, and within the atom, where our protons and neutrons are, keeping it together is called the nucleus. Just like our cells have a nucleus where our DNA is stored. Okay, so if you ever heard the joke, don't trust an atom because they make up everything, that is very true because atoms are what make up everything. They are so small that we can't see them with the human eye. But without them, we wouldn't have anything. We wouldn't have wood. We wouldn't have air. We wouldn't have cells. All right, so now we're going to scroll down to this box here. Atoms have the same number of protons as they do electrons. So I'm just going to highlight protons and electrons. And in a different color, I'm going to highlight the same. So it takes one glance to see same protons is the same as electrons. All right, then I'm going to tell you one more thing. The amount of protons, which is the same of the amount of electrons, is the same amount as your atomic number. Not letting me erase that. Atomic number equals protons equals electrons. But not added together, because added together our protons and our neutrons, that gives us atomic weight. But if we were just to use the one number, the amount of protons, which is the same number as the amount of electrons, that is the same number as the atomic number. So make sure that you write that on your page. Okay, then go back up to our atom here. Apparently one of my electrons got erased. How many electrons do we have? So that means how many protons should we have? Do we have that amount of protons in our nucleus? Okay, and then how many neutrons do we have? So we should be able to say that 6 electrons, 6 protons, 6 neutrons. Now don't let this fool you that neutrons is going to be the same number as electrons and protons. It is not, it just happens to be in this one. Okay, so our number here, 6, is our atomic number. So now we need to go to a periodic table. And I have one available for you here from ptable.com. It is a super cool periodic table, if it ever loads. There we go. So it will highlight things for you. Oh, cool, there's an app. I'm gonna install that. There we go. Cool, I got an app. All right. So we are going to look for our atomic number of 6. I'm just trying to make this back to normal. There we go. All right, so what is our atomic number 6? Ah, excellent. Okay, so how to read the periodic table is okay, so we read it like reading a book. So start at hydrogen, go all the way over to helium, then we go back around, start at lithium, to beryllium, to boron, to carbon, to nitrogen, to oxygen, to fluorine, and then you just continue doing that all the way down for your atomic number. Okay, then there is also another way that you can read the periodic table, and that is called your group number versus your period number. So your group number, if you're writing this in a notebook, I would say is 1 through 18. And those are columns. So column or group number 14. Then I want period 2, which is a row. Periods are 1 through 7, and they are rows. So if I said group number 14, period 2 has atomic mass or atomic number 6, what am I looking at? The other way to do this would be to put your finger on 14 and your right finger on 14, your left hand finger on 2 of period. Your 14 finger should go down just 1, and your 2 should go all the way across until it meets the finger on 14. And that gives us carbon. Okay, so carbon is our answer. Carbon has an atomic weight of 12. So let's go back to our drawing here. That means that when you add protons and neutrons together, you should get 12, which that is our atomic. Uh-oh. There's a T here. I can't see it. That is your atomic mass. So we should have 12 total in the nucleus here. And that tells us that this is carbon we're looking at. All right, so another way for us to get neutrons if we don't have our neutron number is atomic mass subtract what two things make up the nucleus. If we're looking for neutrons, then we can't use neutrons. So that leaves us protons. So that gives us our neutron number. And it's hard to write that small. Since our protons number is the same as our electrons number in a normal state, we could also say atomic mass subtract electrons equals neutrons. All right, so with those equations written, now we are going to move on to lithium. It tells us that this is lithium. So let's start coloring. All right, now that it is all colored, how many electrons do we have? And how many protons? And how many neutrons? All right, hopefully you said 3 electrons, 3 protons, and 4 neutrons. We can gather that information just by counting on the drawing, or we know that 3 is our atomic number. So we can go to our periodic table, and atomic number 3 is lithium. That gives us an atomic weight of 7. 3 plus 4 equals 7, which is the amount total in our nucleus. Okay, now we're going to scroll up and we're going to do a challenge. So this one here is incorrect, and we need to make it correct. So we know how many electrons we have. 5. Electrons is not the thing that is incorrect. None of the things in the middle are labeled. On this atom entirely, none of it is labeled. However, the electrons are correct. So that means that we must have what in our nucleus to the amount of 5. Hopefully you said protons. So we need 5 protons. Color our protons. Okay, so now we need to go to the periodic table and look for atomic number 5. It is in group number 13, period 2. Hopefully you found boron. Boron has an atomic mass of 11. So 11 subtract 5 equals 6. Now, in our nucleus right now, we only have 3 neutrons. So that means we need to add some neutrons here. How many neutrons do we need to add in order to get our total atomic mass to be correct? Three, because we already have 3. And we need 6 total neutrons to make it correct. We also identified that this is boron. That was our atomic mass. Subtracting our protons gave us neutron. Make sure to label it, because then when you look back at this, it's not just going to be random numbers. So we should also go down and label our one from before. So I'm just going to draw an arrow of where I got those 2 from and a line to atomic mass there. And then I don't believe we did this on lithium. So lithium we identified having an atomic number of 3 and the atomic mass of, what's 3 plus 4? 7. All right, so with that, we have now finished the sheet for atoms, the things that make up everything. And we should have a basic understanding of what electrons, protons, and neutrons are, how they make up an atom, how the nucleus is an invisible force field keeping the protons and neutrons together. I also want to tell you that this image that we use to draw out, it does not actually look like that. It is just the easiest way to draw it. However, if we go to electrons here on our periodic table, it shows us what each orbital actually looks like and is represented. And it's a lot harder to draw our electrons in the form of the orbital shape that it actually is. And it just keeps getting more complicated from there. I'm trying to get it to change, but there we go. There's a good one. So see, this one has a lot of orbitals, and that's how it actually is arranged in real life. But that is very difficult to represent on paper. So we use the circle version, and it does make it so much easier to do that. All right, so that is all for this lesson. There is a reading to go with this from the ACE Science notebook that I have attached to Google Classroom.